All right, good day, everyone, and I hope you are having a great day still. And this time, our lesson is all about finding the roots of our equation, of our polynomial equation. But this time, we will see. But first, let's find the product of this. If you have x plus 2 times the quantity x minus 3 times the quantity x plus 4, if you will actually multiply these three binomials, you could actually see that each of the binomial factors here have a leading coefficient of 1, right? So we have here 1, 1, 1. And if you could actually multiply on your own, you would find out that the product of these three, it's x sub 3 plus, x cubed plus 3x squared minus 10x minus 24. And what have you noticed with the numbers in red? You could see that we have here 2 plus 2, negative minus 3, and plus 4. You could see that the constant here is negative 24, right? And we could actually see that the product of the last of this, of plus 2, negative 3, and plus 4, is also the constant of the polynomial in standard form. That's why we have to remember this, ladies and gentlemen, that if you multiply binomials having leading coefficient 1, then what is true is in multiplying linear binomials with leading coefficients equal to 1, the resulting constant of the product is equal to the product of the constants of the binomials. That is why if you see this, if you see this, without actually, if you are just asked what's the constant term of the product, just say, okay, 2 times negative 3 times 4, which is negative 24. And it's a simple thing, but it's very useful for us to determine the roots of equations, of polynomial equations, especially of higher degree. Say degree 3, degree 4, degree 5, and so on. Now, let's have exercises. Let's factor and solve each polynomial equation. When we say solving polynomial equations, we are going to look for all of the roots of that equation. Say we have the first one, x cubed minus 6x squared minus 9x plus 14 equals 0. Now, I don't know if you could factor this easily, and factoring by grouping may be difficult at some point. But we could see that if we are going to apply that concept earlier, the lead, the leading coefficient is 1 here, so okay, no big deal. And the constant is 14. And we know that the degree is 3, so therefore we are sure that the number of roots is also 3. And since the product of the constants is 14, then we have to get all the possible factors of 14. We know that 14, the factors of 14 are 1, 2, 7, and 14. But how come I included the plus minus in front? Why is that so? Because for example, 14 could be 1 times 14 plus positive 1 times positive 14. Positive 14 could also be negative 1 times negative 14. It could be positive 2 times positive 7. It could be negative 2 times negative 7 as well. That's why if we take the possible factors of the constant, let us also consider placing a plus minus. And hence, the possible factors of the polynomial equation are, just place here a plus minus. We have x plus minus 1, x plus minus 2. For the third one, we have x plus minus 7. And for the fourth one, we have x plus minus 14. You see, we have here two factors. We have x plus 1, we have x minus 1. So that's 2 here. And there are a maximum of 8. There is a maximum of 8 possible factors of this polynomial. And how do we know which of these are the factors? Because some of the factors some of them will be factors, but some of them will not be. And whether we will like it or not, we will perform synthetic division, but this time this involves trial and error. Whether we like it or not, we have to do some sort of trial and error here. Some of our attempts will be successful, some of the attempts will not be successful. And you might have a long time here if you are not able to jackpot the factors. So, for example, among these possible factors, let us try x plus 1. And if we divide it, let's use synthetic division. Remember, you could use, remember, no, if we could still recall our past lesson, we could say that a certain linear binomial divisor is a factor of a given polynomial if the remainder is 0. And to determine if the remainder is 0, you could perform long division, synthetic division, or the remainder theorem. For our class now, we will be performing the synthetic division. And I hope you could still recall how to do that. So we have here remember that the coefficients here should be in descending. The powers should be descending order. We have 3, 2, 1, 0. And you could see that there are no missing exponents or terms. In terms of exponents, no, we have 3 degree. In terms of degrees, we have 3, 2, 1, 0. And we just copy the coefficients. We have here 1, -6, -9, and 14. And we have here your divisor x plus 1. So x plus 1 equals 0. That means we have here -1. That's why we have here. Let's try if -1 works. If -1 as a root works. So bringing down 1. So multiply, after bringing down, multiply. -1 times 1 will be -1. Then remember, if you are doing synthetic division, the next step is for you to add. We have -6 plus -1, which is -7. Multiply again. -1 times -7, that's 7. Adding them will give us -2. -1 times -2, it's 2. So we have here 2. And adding gives us 16. And so, is x plus 1 a factor? Remember that if you divide by a linear binomial divisor, the last number here in the last row is the remainder. Is x plus 1 a factor? And the answer is no. X plus 1 is not a factor because for x plus 1 to be a factor, the remainder has to be 0. But since the remainder is 0, so therefore, it's a sufficient evidence to say that x plus 1 is not a factor or -1 is not a root. How about x minus 1? Because this one, no, whether we like it or not, we really have to do trial and error. Let's try x minus 1. Hopefully, it will work. If you try x minus 1, so the same thing. So equate the constant, the x minus 1 to 0. That's x equals 1 we have here. Performing synthetic division again, we have 1. Then multiply them. 1 times 1 will be 1. Adding them, -6 plus 1, we have -5. 1 times -5, it's -5. And adding them gives -14. Multiplying again, that's 1 times -14, that's -14. And we could see that their sum is 0. And we might ask, is x minus 1 a factor? And the answer is yes. Because the remainder here is 0. And so we could say that x minus 1 is a factor, or in fact, this one here is a root of our polynomial equation. And remember that the degree, this 1, negative 5, negative 14 here, are the coefficients of our quotient. And recall as well that if you divide, no, using synthetic division, the degree of the quotient is equal to the degree of the dividend minus the degree of our divisor. So with degree 3, degree 1. So 3 minus 1, we have 2. So this should be degree 2. So this should be x squared. That's x squared minus 5x minus 14. And remember, this is still factorable. This is already quadratic, no? And so the technique is, if you have already a quadratic polynomial, better factor it. In this case, we have x minus 7 times the quantity x plus 2 as the factors of this. Therefore, we could say that x cubed minus 6x squared minus 9x plus 14 equals 0 could be factored as we have the first one, x minus 1. We have x minus 7 and x plus 2. And these are the factors equals 0. And equating each linear binomial divisor to 0, we have the roots are x sub 1, 1, x sub 2, 7, and x sub 3, negative 2. All right? So therefore, you could see, no, that this time, whether we like it or not, we really have to do some sort of trial and error for this. Let's have the second example. How about if you have x to the fourth minus 2x cubed minus 15x squared minus 4x plus 20 equals 0? You could see here that the number of roots should be 4 because the degree is 4. And the leading coefficient is here is 1. Okay, so no problem. And since our constant here is 20, and based on the concept earlier that we discussed, so we have to look for the factors of our constant. And we know that 20, the factors of 20 are 1, 2, 4, 5, and 10, and 20. But we have to place a plus minus symbol to each of those. Hence, the possible factors of the polynomial equation are x plus minus 1, x plus minus 2, x plus minus 4, x plus minus 5, x plus minus 10, and x plus minus 20. So you could see there are 12 possible factors. Unluckily, or unfortunately, some of these 12 possible factors are not the real factors of our polynomial. And so this time, it's now up to you to choose some of the factors, to test them out, and check which of them really satisfies the equation. So for example, let us try x plus 1. Let's try dividing them. So you could see that's still complete. We have degree 4, 3, 2, 1, 0. And writing the coefficients, we have 1, negative 2, negative 15, negative 4, and 20. And x plus 1 equals 0. So let's we have x equals negative 1 here. Let's see if negative 1 is a root. Take note, I started with x plus 1, but in your actual work, you may start with any factor or with any linear binomial. Performing synthetic division, we have 1, bring down 1, then multiply them, negative 1 times 1, that's negative 1. Their sum is negative 3. Next, we have negative 1 times negative 3, which is positive 3. Place that under 15, negative 15. Their sum is negative 12. Multiplying again, negative 1 times negative 12 will be 12. The sum is 8. Negative 1 times 8 will be negative 8. And you could see that the remainder here is 12. And is x plus 1 a factor? No, x plus 1 is not a factor. So this is one attempt that did not work. Let us try other factors. Let's try x minus 1. So the same thing, no? However, if I equate x minus 1 equals 0, then x equals 1. That's why I place here 1 at this part here. Next, let's perform our synthetic division. Bring down 1, then multiply 1 times 1. We have 1. You add them. Uh, their sum is negative 1. 1 times negative 1 will be negative 1. And their sum here, it's negative 16. 1 times negative 16 will be negative 16. Place that under negative 4. Negative 4 plus negative 16, it's 0. I mean, negative 20. 1 times negative 20 is negative 20. And we could see that the remainder here is in fact 0. So therefore, it is a sufficient evidence to say that x minus 1 is a factor of this fourth degree polynomial. But again, this is degree 4, degree 1. So 4 minus 1, we have 3. Hence, these are the coefficients of a polynomial of degree 3 or a cubic polynomial. And this is x cubed minus x squared minus 16x minus 20. And for x cubed minus 6x squared minus 16x minus 20 again, we still have to use this one now. We will use this one now and choose again any of the possible divisors, linear binomials as our divisor. And let's see which of them will work. I suggest that you stop only if you arrive to a quadratic equation because you could tell if a quadratic equation is factorable or not. We have here cubic. So in my case, I tried x minus 2. Again, it's in the end, no, later on in the actual test, it's your decision now if you would like to try of whatever linear binomial divisor you would like to try. So I'm trying x minus 2. So we have here performing synthetic division. Bring down 1, then multiplying, we have 2 there. Adding, we have negative 1 plus 2, that's 1. Multiplying, 2 times 1, we have 2. Adding them, we have negative 14. Multiplying that, that's negative 28. Adding them gives negative 48. So is x minus 2 a factor? And the answer is of course, it's not, because the remainder is not 0. So x minus 2 is an attempt that did not work. Let me try something else. Let me try x plus 2. If we try x plus 2, then of course, x plus 2 equals 0, so that's negative 2. Let me try. If negative 2 is a root, bring down 1. Multiplying them, we have negative 2. Adding them gives negative 3. Next, negative 2 times negative 3, we have 6. Positive 6. Adding them gives negative 10. Negative 2 times negative 10 is positive 20. And adding them gives 0, right? Hence, therefore, we could say that since the remainder here is 0, then x plus 2 is a factor of x cubed minus x squared minus 16x minus 20. So, what's the degree? This is degree 3. This is degree 1. So, 3 minus 1, 2. Hence, 1, negative 3, and negative 10 are the coefficients of the quadratic equation x squared minus 3x minus 10. And this is now factorable as what? What are the factors of these? We have x plus 2 and x minus 5. Hence, earlier, the first factor that worked earlier was what? What were those? The very first one that worked earlier, we have x minus 1, x plus 2, x plus 2, another x plus 2, and x minus 5 equals 0. And of course, since the original equation earlier has degree 4, we are expecting 4 roots. And of course, we have here x minus 1 equals 0. So the first root is x sub 1 is 1. Here, x sub 2 is negative 2. X sub 3 is negative 2. And x sub 4 is 5. Or you could also say the roots are 1, negative 2 multiplicity 2 because negative 2 appeared twice, and x sub and the other root is 5. The remaining root is 5. All right. Now, I hope that you understand this. Let's have another example. Factor and solve each polynomial equation. We have x cubed minus 2x squared plus 4x minus 8 equals 0. Now, for this one, for the solution, again, for you to do this method, it's important that the leading coefficient here should be 1. And you just get the factors of 8. So the factors of negative 8 no, are plus minus 1, plus minus 2, plus minus 4, and plus minus 8. Hence, the possible factors are x plus minus 1, x plus minus 2, x plus minus 4, and x plus minus 8. So I place here the list of possible factors. Let us now do some sort of trial and error. Let's try x plus 1. So using synthetic division, we have bring down 1, then multiplying them, 1 times negative 1 will be negative 1. Next one will be adding them, we have negative 3. Negative 1 times negative 3 will be plus 3. 4 plus 3 is 7. Negative 1 times 7, it's negative 7. Negative 15 is our remainder. So therefore, x plus 1 is not a factor of this polynomial. Let's try x minus 1. Now, if we try x minus 1, so we have here 1, negative 2, 4, negative 8, and x minus 1 equals 0. So we have here 1. Bring down 1, we have 1. Multiplying them, we have 1. Adding them will be negative 1. 1 times negative 1 will be negative 1. 4 plus negative 1, it's 3. 1 times 3, it's 3. We have negative 5. All right? And still, x minus 1 is not a factor. And this is troublesome sometimes with this method because you might not be able to get the factors or the roots right away with this method. No? So let's have another one. Let's try x minus 2. Okay? Now, how about, will 2 work as a root? Let's see. Bring down 1. Okay, multiplying again. That's 2, 0. Multiplying again, 2 times 0 will be 0. 4 plus 0 will be 4. 2 times 4 will be 8. And you could see that the sum now is 0. Hence, is x minus 2 a factor? Because the remainder is 0? And the answer is, of course, yes. And x minus 2 here is a factor. And so doing this or using this result, so this is degree 3, degree 1. So 3 minus 1, that's 2. So this should be quadratic. In fact, this is x squared plus 0x plus 4. But again, it's just 0. So, um, therefore, we could say that we know that x squared plus 4 is no longer factorable, right? Therefore, the given polynomial equals 0 is could be factored as x minus 2 times the quantity x squared plus 4. We know that the first root is already 2 here because x minus 2 equals 0 or x is 2. But we know that x squared plus 4 is not factorable. Or so it is the case. How about the roots of x squared plus 4? So you may use the quadratic formula if you wish, or adding both sides negative 4, we have x squared equals negative 4. So we have, and we now take the square root of both sides. But we have to remember, no, our lesson last first grading period, and even in your grade 9, that if you take the square root of both sides, there should be a plus minus symbol in between. So we have plus minus square root of negative 4. And we know that 4 could be expressed as 4, I mean negative 4 could be expressed as the product of 4 and negative 1. And so we have x equals plus minus. The square root of 4 is 2. The square root of negative 1 is I. So we have x equals plus minus 2i. Remember, people, in your final answer, the square root symbol should not have a negative inside the radical. If that happens, then take the square root of negative 1, which is I. Therefore, the three roots of x cubed minus 2x squared plus 4x minus 8 equals 0 are 2, 2i, and negative 2i. All right. So if you have questions later on, I will be addressing them next meeting. But again, guys, there is another way of doing this. Remember, you could do factoring by grouping here. So I grouped together the first two terms. I place here parentheses, group them. 4x minus 8 is also another group. The GCF in the first group is x squared. So factoring x squared out, I have x cubed divided by x squared, which is x. Negative 2x squared divided by x squared, it's negative 2. Plus, in the second group, 4x minus 8, the GCF here is 4. So factoring 4 out, we have 4x divided by 4. What's inside the parentheses is x. Negative 8 divided by 4, that's negative 2. And we could see that in these two, x minus 2 is a common factor. So we can factor that out. And we have x minus 2 times a quantity x squared plus 4 equals 0. And you could see, no, that the roots of this equation, that we arrive to the same factors using the synthetic division earlier. And with such, therefore, of course, same roots. How about for the third one, letter D? Factor and solve each polynomial equation. From here, we could see that, take note, no, if you could see, you don't have a constant, right? And if you don't have a constant, you cannot directly use the method I gave you earlier. But always remember this. We know that the degree is 5. And each term here, so we are expecting 5 roots. And each term here has variable. And if there is a variable, then it is important that you factor out the GCF. Take note, that if everything has a variable here, most likely the variable, you have a GCF, which also contains a variable. Which is a variable, for example. We have here, you could see that the GCF of all the terms is x squared. So factoring out x squared, we have x squared times the quantity x cubed plus 3x squared minus 4x minus 12 equals 0. And so now you could see, no, we have this. We have now a constant here. Hence, we can see that x sub 1 equals 0 and x sub 2 equals 0. How come? How come I could say that x sub 1 equals 0 and x sub 2 equals 0 already? It is because we have here x squared. And this is x times x. And equating each to 0, which means your first two roots are both 0. And now what we have to look for is the roots of this cubic polynomial. And you see that the leading coefficient is 1 here, and the constant is negative 12. So you look for the factors of negative 12, which are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12, and just attach an x in front of them. Your possible factors are x plus minus 1, x plus minus 2, x plus minus 3, x plus minus 4, x plus minus 6, and x plus minus 12. And you could now do your own trial and error. No, you could do your trial and error. But again, guys, it's just a char. Why? Because in this case, if you are just keen enough, don't worry. No, if you are keen enough, you don't need to do the trial and error earlier. You can do factoring by grouping. We could see that if we group the first two terms, we have x cubed plus 3x squared plus the second group, negative 4x minus 12. The GCF of the first group is x squared. So factoring out x squared, we have x squared times a quantity x plus 3. In the second group, we could factor out negative 4. And with such, what is left inside is what we have is negative 4 times the quantity x plus 3. We could see that x plus 3 is the GCF of the two. So factoring out x plus 3, we have x plus 3 times the quantity x squared minus 4. And hence, x squared minus 4 is a difference of 2 squared. And we know that x squared minus 4 is a difference of 2 squares. And the factors of this is x minus 2 times the quantity x plus 2. Hence, the complete factored form of x cubed plus 3x squared minus 4x minus 12 is x plus 3 times the quantity x minus 2 times the quantity x plus 2. And therefore, your x sub 1 earlier is 0, your x sub 2 is 0. Your third root is negative 3 because you have x plus 3 equals 0. That's x sub 3 equals negative 3. X minus 2 equals 0, or x sub 4 is 2. X plus 2 equals 0, or your x sub 5 is negative 2. So therefore, the roots are, if you answered in this way, this is correct. But if you write them in statement form, for example, you may say the roots are 0, multiplicity 2, because 0 appeared twice as a root, negative 3, and you could see we have here 2 and negative 2, no? So we could say plus minus 2, combining them into a single expression. Okay, so again, if you have questions or clarifications, it will be addressed this Wednesday. And here is here's another one. If 2 square root of 2 is a root of x cubed minus 12x squared minus 8x plus 96 equals 0, find the other roots. Remember, by the theorem we discussed earlier, we know that 2 square root of 2 is irrational. And if the positive is present, then the negative should also be there. By the quadratic third roots theorem, we could say that negative 2 square root of 2 is also a root, right? And combining them into a single expression, we have x equals plus minus 2 square root of 2. And since we have already isolated the term with a plus minus symbol, then squaring both sides gives x squared equals 2 squared is 4. The square of square root of 2 is 2. So we have x squared equals 8, or x squared minus 8 equals 0. So therefore, this is another polynomial. And you could see, therefore, that since 2 square root of 2 and negative 2 square root of 2 are roots, and therefore x squared minus 8 is the polynomial equation whose roots are 2 square root of 2 and negative 2 square root of 2. Therefore, tandaan natin guys, we have to remember that this x squared minus 8 is a factor of x cubed minus 12x squared minus 8x plus 96 equals 0. And since factor siya, di ba degree 3 ito, degree 2, so may isa pang factor na natitira. And for us to find the other factor, we have to do division. So we will divide now this polynomial with x squared minus 8. And you could see, no, we are going to divide now with a quadratic uh, divisor. So we have 3, 2, 1, 0. Okay, so we have 1, negative 12, negative 8, 96. And we know that we have x squared minus 8, but we have degree 2. Degree 0, we don't have present there. It's just here. So we have x squared plus 0x minus 8. And remember how to divide with a quadratic divisor. So the b here is 0. We interchange the signs of, we change the sign of the coefficient of x and that of the coefficient of 8. If we change the sign of 0, 0 is still 0. No? So never mind, because 0 is neither positive nor negative. We change the sign of negative 8. It became positive 8 here. Performing synthetic division now, we have 1. Then multiplying each of this to 0 and 8, we have 0 times 1, we have 0. Place it here. 8 times 1, we have 8. Next one, so you add the second column, negative 12 plus 0, we have negative 12. Next, multiply each of 0 and 8 to negative 12. So 0 times negative 12 will be 0. Place it in the third column. 8 times negative 12 will be negative 96. And with such, we have an entry already for the last column. So it's time to add everything, the remaining two columns. So the sum here is 0. And the last sum is also 0. Okay? And the remaining two numbers there is your remainder, by the way. And as expected, since x squared minus 8 has to be a factor, then, of course, the remainder has to be 0. Therefore, the degree 3, degree 2, so this should be degree 1. And this is x minus 12. And here, so x minus 12 equals 0, or x sub 3 is 12. Therefore, guys, since one of the factors was already given, one of the factors or the roots earlier was given, no? So the degree is 3. Therefore, we are looking for the other two factors or the other two roots. So the other two roots are negative 2 square root of 2 and 12. Take note, you are asked only of other roots. And so therefore, there's no need for you to give the root that was already presented. So that's it for this one. And let's have another one. If negative 1 plus I square root of 3 is a root of x to the fourth plus 3x cubed minus 8x minus 24 equals 0, find the other roots. We have degree 4. So we are expecting 4 roots. But one out of 4 roots was already given. Hence, we need to look for 3 more roots. And however, don't worry, no, if we look for three more roots, we could see that negative 1 plus I square root of 3 is a complex conjugate. And with the complex conjugate roots theorem earlier, we could say that its conjugate, which is negative 1 minus I square root of 3, is also a root. So, minus 1 sa roots natin, no? This is the one root. And we need to look for two other roots. But again, uh, we could see that we can combine these two roots as a single expression. We have x equals negative 1 plus minus I square root of 3. Adding 1 both sides will be x plus 1 quantity squared equals the square of the quantity I square root of 3 plus minus I square root of 3. We did it directly. Squaring the left hand side will be x squared plus 2x plus 1. If you square a plus minus, just remove the plus minus. Square root of I is I squared, which is negative 1. The square of square root of negative 3, it's 3. The right hand side simplifies to negative 3, and adding both sides by 3 will give us x squared plus 2x plus 4 equals 0. All right? But again, guys, it's not yet the final answer. Remember that since negative 1 plus minus I square root of 3 are roots of this, it follows therefore that the quadratic polynomial having these two roots should be a factor of x to the fourth plus 3x cubed minus 8x minus 24. With such, how do we determine the other factor? Of course, by using division. So this time, we can perform either long division or synthetic division. But for my case, I prefer to use synthetic division. So in the given polynomial, we have degree 4, 3. We don't have degree 2. We have 1 and 0. That's why it's imperative that it's important to have the plus 0x squared here. We have degree 4, 3, 2, 1, 0. And there's no missing degree for our divisor. So we have your x squared plus 2x plus 4. And copying here, no, we have 1, 3, 0, negative 8, negative 24 as the coefficients here. And here, since the leading coefficient is 1, we just have to change the signs of the coefficient of x and that of our constant. So here, if you change the sign here, that would be negative 2. The positive 4 here will become negative 4. Now, performing synthetic division, bring down the 1 first, the first number. Multiplying each term, negative 2 times 1 will give us negative 2. Negative 4 times 1 gives us negative 4. And we're done getting the sum of the first column. It's time now to get the sum of the second column. We have 3 plus negative 2, which is 1. And we will multiply this 1 again to each of this. And we have negative 2, negative 4 here. So let's add now the numbers in the third column. We have negative 6. And multiplying each of negative 2 and negative 4 to negative 6, negative 2 times negative 6 is 12. We'll put it in this column, 12 here. And the 24 will be placed at the last column. Since we already have an entry in the last column, we can now add the two remaining columns. And as expected, the sums for the last two columns should be 0. Why? Because since x squared plus 2x plus 4 is a factor of the quartic polynomial. So we have your x squared plus x minus 6 as the other factor. But this is quadratic and this is still factorable, no? And your x squared plus x minus 6 could still be factored into x minus 2 times the quantity x plus 3. And the other two roots are equating each of these to 0. We have x minus 2 equals 0. That's 2 as our x sub 3. And x plus 3 equals 0. That's x sub 4 equals negative 3. Hence, the other roots are the conjugate of the given, which is negative 1 minus I square root of 3, 2, and negative 3. Again, if you have questions or clarifications, feel free to speak them out on Wednesday or message me from time to time. And this is the activity associated with such. With that, God bless everyone and take care.